So welcome to another session. Today we are going to look at block diagrams, that is under control systems. And you'll find that the block diagrams are simply pictorial representation that usually show the cause-effect relationship between the input and the output of a physical system. In most cases, we usually have, if we have an equipment, maybe we can talk of the radio, we can always represent it in terms of blocks, whereby these blocks usually have components that work in order to achieve a related function. Like we can talk of the receiver, we can talk of the transmitter, we can talk of the amplifiers. So the amplifier, it is not that it is one component, but rather it is just several components that are grouped together in order to form that particular function of amplification. So when you talk about the block diagrams, one of the important features of the block diagram is always that it is supposed to show the relationship or give a description of what happens to the input for it to become an output. So you must have what is, there has to be the system component or the control system component that will change whatever is at the input in order to form an output. And basically a simple block diagram can be shown. So you can have a simple block diagram whereby you have the input. You have the input. So this is the input source. You can call it the input source. Then from the input source we can have what we call the control system components. Control system components. Then there we can have the output, and of course we must have the energy source. So there we can have the output, and here we can have the energy source. So that is a basic block diagram of that is a basic block diagram that can be used. So what you can see is that there is the input, that is the input source, there is the input source, and then the input source interacts with the control system components with the combination of the energy source in order to give an output signal. So they interact in order to give an output signal, and that is why we were saying that it is a pictorial representation that is supposed to show a cause and effect relationship between the input and the output of a physical system. So you will find that there is the input, then after the input there is the control components that interact with the energy source in order to give the output signal. When you talk of the signals, they usually follow paths, and this one will always depend on the quantity that you are trying to measure. Like for electrical, for electrical systems, the signal paths are always electrical wires when you talk of the electrical signals. And for the pneumatic tubes, we usually have we have pneumatic tubes when you talk of the pressure, and also when you talk of the hydraulic lines, and also mechanical linkages for the force, and so on and so forth. So those are just the paths that are always followed. So these ones are the signal paths as per the physical quantities. So I want us to go to something that we can refer to as block diagram simplification. So when you talk about the block diagram simplification, then basically what you are talking about is what we are talking about as far as the block diagram simplification is we are talking about a control system usually consists of several kinds of components. And these components usually represent different sections, and the sections with the different components can be grouped together in order to form a block. And these components that are replaced with the blocks, each and every block usually contain equations. And these equations are what we usually use in the analysis of these particular systems. So in this case, we are talking of blocks that are consisting of equations. And in most cases, the equations that we are talking about in this case are always differential equations. So each and every block is always represented by appropriate differential equation So when you talk of the block diagram simplification, when we want to get the transfer function of a block diagram, whereby the transfer function is always the ratio of Laplace transform of the output over the ratio of the Laplace transform of the output to the ratio of the Laplace transform of the input. And when you want to obtain that, then we usually talk about something that we usually call the canonical form of a block diagram. Under block diagram simplification, we can talk about canonical form of the block diagram. Canonical form of the block diagram. So when you talk about a canonical form of the block diagram, then we are simply talking about a block diagram that only has one forward element and one feedback element. So you'll find that and it represents a closed loop system. So if a system is represented by several block diagrams, then it can be simplified by reducing those block diagrams to canonical form. That is a block diagram that has got only one forward element and one feedback element, and this one can be just as what we have here. So we can have a canonical block diagram here, whereby you can have that. So you have that. Yeah, that is the feedback path. So in this case, this is our output, that is C of S. This is our input, that is R of S. Then at this point we have error, which is E of S. Then here we have G, that is the forward element, which is also G of S. And here we have the feedback. Of course, here we have H of S. And then here we have what we refer to as B of S. So these ones are what we had already defined, what we defined earlier when we were talking about the terminologies. So from this particular block diagram, the feedback here can either be positive or negative. But we know that we should know that if stability is supposed to be achieved, then in most cases the feedback for the control systems is always negative in order to achieve stability. So from this particular block diagram, we can define some terms that are going to be very, very important in defining or getting these particular ratios. So the first, we can talk of the G in this case, and G is the forward element transfer function. So this is forward element transfer function. The next one that we can talk about is H, which is the feedback element transfer function. H is the feedback element transfer function. Feedback element transfer function. Then we can also talk about what we can say to be GH, which is known as the open loop transfer function. GH, which is the open loop transfer function. GH is the open loop transfer function. Then we have C over R. C all over R, which is what we refer to as the control ratio. We can refer to it as control ratio, or again we can refer to it as, at times we refer to it as closed loop transfer function, closed loop transfer function. That is what we usually commonly refer to it as. Then we also have B over R, which is basically the primary feedback ratio. Primary feedback ratio. We have B over R, which is the primary feedback ratio, and then we also have E over R, which is what we refer to as the error ratio, which is referred to as the error ratio. So we want to, from this particular block diagram, we want to find how, we want to look at how are we going to get all these ratios that we are talking about and express them in terms of the elements or in terms of the parameters that we have in the block diagram. So we can start by expressing these ones in terms of G and H in order to obtain the various ratios. I can talk of the control ratio, primary feedback ratio, or even the error ratio. So we can start by looking at how do we obtain the error ratio. That is from that particular block diagram. So in that case, we can talk of to obtain C all over R, which is the transfer function of that. There are three equations that are always very, very important in this case. The first equation is how do we get the error? E of S is always given us, E of S is given us R plus or minus B. It's given us R plus or minus B. We can call that one equation 1. Then we can talk about the second equation, which can be C of S. The C of S here will be that particular error times the forward element. So it's going to be G of S, E of S. And the third equation, so that one we can talk of it as the second equation. Then the third equation, we can talk about B of S. And B of S, because it is now what we have here, it is the feedback. So it is C of S, that part that is fed. We can start with H. It's H of S, B times C of S. So it's going to be that. So that is what we can have in that case. So that is our third equation. So for us to obtain C over R, we can use using the second equation. So we can substitute these values in order to obtain that. So substituting from equation 2. From equation 2, where we talk of C of S is equals to G of S, E of S. And we know that E of S is also equals to, so we can substituting for E, whereby we know that is from equation 1. From equation 1, we can now say that C of S will now be equals to G of S into E is R plus or minus B. So that is what we have, which is going to be given, which is going to give us G R plus B G or GB. You can talk of GB, and that is still the same as C of S. That is still the same as C of S. So in that case, we can have that one. In that case, we can have that one. Then again, we know what B is. So from substituting for B in equation 3. In equation 3. So if we do that, then we have C of S is going to be given by G R plus G H C. Then we can now make C over R to be the subject, and that one means that of course it will be plus or minus, maintain the sign. That one means that we can collect what has C, we can put them on the left hand side, so that we are going to have C of S. Of course, we have C of S into 1 plus, of course, if that one goes up there, it will change. 1 plus GH is equals to GR. And then now, if we make, of course, there is R of S. Of course, all of them are now in frequency domain, and therefore, we talk of R of S. And if that one happens that way, then we are going to have our transfer function. We can take now C of S, and therefore C of S all over R of S will be given by G all over, of course, G of S all over 1 plus GH. We can just have it as G of S over 1 plus And of course, that one is, we can have the minus up there. What the minus up there signifies is that if the feedback is positive, then this will be negative. And if the feedback is negative, then that one will be positive. And that is how the formula on how to get the transfer function in terms of G and C, or in terms of G and H, as we had obtained. Now we can obtain the second ratio, which is now B over R. B all over R. So B over R, and this one we referred to it as the primary feedback ratio. The B over R is the primary feedback ratio. So if we want to get B over R, then we just start from equation 3, B over R. To obtain B over R, B all over R, then from equation 3, which we are saying that B is equals to HC. So if B is equals to HC, we know what C is, and we also know what, we know what C is, so we can say, therefore, substituting for C, so the C, we know what it is, C in equation 2, from equation 2, substituting for C from equation 2, we are going to say B is equals to H, we have it as C is GE. So when we talk of C, so we can have that one as GHE. So it's going to be GHE. And then we know what E is, so substituting for E in equation 1, substituting for E in equation 1. So if we substitute for E in equation 1, we are going to have B is going to be given by GH into R plus or minus B, of which if you open that, then we have B is going to be GHR plus GHB, of course, plus or minus. And then we want to make a B over R to be the subject, so that will be the same as we are going to have GHR plus GHB. So this one, when it comes to that side, of course, it will change. So we are going to have B minus or plus GHB is equals to GHR, of which now we can simply say that B into 1 plus GH is equals to GHR. And then we make B over R to be the subject. If you make B over R to be the subject of the formula, then we are going to have B all over R is going to be given by, of course, that one now comes up there. It's going to be given by, B over R will be given by GH all over 1, that one, GH. And that is what we call the primary feedback ratio. That is what we refer to as the primary feedback ratio. So we can also get the error ratio, E over R. For us to get E over R, to obtain E over R, to obtain E all over R, then we go to the first equation, of which we are going to say, from the equation 1, we have E of S is going to be given by R plus or minus B. And we know that B again is also equals to HC. So E of S is also going to be to give us R plus, that is from B is equals to HC. So we can substitute for B and make it to be equals to HC. So there we are going to have HC. Then again we know what C is. C is also equals to GE. So we can substitute E all over S again. From C here, we can now say that is going to be R plus H, or we can simply say GHE. And of course, we can now make, we can move e to the other side of the equation. Of course, that one will be that way. So if we move it, so e of s into 1 plus minus that gh is equals to r. And in that case, e, of course, that is r of s. In that case, e of s all over r of s is going to give us what we say to be 1 all over 1 that gh. And that is what we refer to as the error ratio. So those ones are the ratios that we did talk about, and that is how we can obtain those particular ratios.